Alexis, what common factor can we take out? 7. So we're going to divide them both by 7. And take 7 on the outside. And then, Alexis, what's left inside? 2x plus 1. Good. All right, the next one does not have a common factor. But Kyle, did you factor that with difference of squares?
What?
Did you factor it with difference of squares? How did you factor it?
X then 3x plus 3.
Good. So that is the difference of squares when you take the square root of the first term and you take the square root of the second term. So the square root of x squared is x, and the square root of 9 is 3, and then you make one with a plus and one with a minus. So minus and plus. You always check for a common factor first, but if these are both perfect squares, then that's how you do it, okay? All right, the next one was from our notes last class, and it was on the first side, which was the slightly easier method. You had to find two numbers that multiply to 3 and add to -4. Jacob, are you saying you have the answers?
Yeah.
Okay, go for it.
-3 and -1.
-3 and -1 multiply to make 3 and add to make -4. Good. How can I write my factors?
X minus 3 and x minus 1.
Well done. All right, so the numbers that multiply to 3 and add to -4 are -3 and -1, and because it was just 1x squared, we were able to do that the easier way. We didn't have to do all the steps, but guess what? If you did all the steps, it worked too. You still got your answer. Okay? All right, the last one is the longer one. In the last one, we have to multiply the first one and the last. Okay? So we have to find two numbers that multiply to 3 times 4, which is 12. And then they're going to add to 8. Did anybody already find those numbers? Skylar, what'd you find? Does 6 and 2 work? Multiply to 12 and add to 8? Good. Thanks, Skylar. Okay. So I'm going to put 6x plus 2x. You are allowed to put 2x plus 6x, but your steps will look different from mine until we get to the answer at the end. In the end, your final answer will be the same. Why do we do that part? So it has to be the long method no matter what. The only difference is you could put 2x plus 6x or 6x plus 2x. And you get to choose. I'm going to suggest you do it the way I'm writing it just so that you can follow my steps. But you can do it the other way too. The steps look a little bit different. All right. So I'm going to put parentheses on the first two and on the last two. And I'm going to factor common factor out of each one. What can I factor out of 3x squared plus 6x? 3x, good. So I take the 3x on the outside, and I'm left with x plus 2 on the inside. All right, what can I factor out of 2x plus 4?
2.
Just 2, right, because the other one doesn't have an x, so just 2. And I have x plus 2. So I have those twins inside the parentheses. That's good news. So then x plus 2 is one of my factors. What's the other one?
6 plus 2.
3x, right? Yeah, plus 2. Good. So it comes from the outside. 3x plus 2. Plus 2. Who has a question? The zero product property says that if you multiply a times b and your answer is 0, then either one is 0 or the other is 0, or they both are 0. So here, 7 times x is 0. Well, 7's not 0. That means x must be what? 0. 5 times x minus 3 is 0. Well, 5 is not 0, so what must be 0? X minus 3. So x minus 3 must equal 0, which means x equals 3. And now this one, I have two different variables. I have x and I have x plus 1. So either x equals 0 or x plus 1 equals 0. One of them has to equal 0, and it could be either one. It's not like a trick. I'm trying to find out which one. It could be either one. So either x equals 0, or if I minus 1 here, x equals negative 1. Either this or this. So when you have something factored and you set it equal to 0, either of the factors could equal 0. And so we use that. We use that to solve. So if I'm trying to solve an equation like this one down here, x squared minus 4x plus 3 equals 0. The way you solve it is you factor it, and you set each factor equal to 0. You can also solve graphically. So if you graph that same equation, you're going to see that it crosses the x-axis at these points where the y is 0. And it's also going to give you the same answers of 1 and 3 that we got 1 and 3 up here. We're going to actually skip the graphing right now so that we can focus on solving by factoring back here. So let's turn to the back. Solving by factoring looks like it has a lot of steps. The steps are really just this. Factor it. First, make sure one side's 0, because you can only use the zero product property if one side is 0. After you make sure one side's 0, factor it, and then set your factors equal to 0. So in example 1, do we have one side equal 0 yet? No, so let's make one side 0 by subtracting this 3x here. Remember that 3x kind of belongs in the middle, so when I rewrite it, I'm going to write x squared minus 3x minus 10 equals 0. So first thing I did was make one side equal 0. Now this is the easier kind of factoring, I know, because there's no number in front of x squared. So I have to find two numbers that multiply to make negative 10 and add to make negative 3. Think in your head if you can find those numbers. Think in your head if you can find those numbers. Multiply to negative 10. Add to negative 3. If you find them, you can tell your neighbor. To your neighbor. All right. So what did you guys get? Positive 2 and negative 5, right. So we're going to have x plus 2 times x minus 5 equals 0. And the interesting thing here is that the answers are going to actually be the opposites of those numbers, right? Because when we set them equal to 0 and we solve, we're going to get their opposites. Let me show you what I mean. And I'm kind of running out of space. I'm going to write over here. So either x plus 2 equals 0 or x minus 5 equals 0. Oh, that's so tiny. Let's see if I can fix that. Either x plus 2 equals 0 or x minus 5 equals 0. And I solve by subtracting the 2. So either x equals negative 2 or add the 5, x equals positive 5. So notice, because we had an equal sign, we had an extra step of solving here. I'm going to do example 2, and then I'm going to give you some time to work on the 2 practice problems below it, okay? In example 2, before I can factor that, I have to take out what? No. I like that you notice that this side is 0, so I don't have to make one side 0. But in factoring, the first step is always to look for what? Greatest common factor. What is it? 2. Because this is an equation, you can actually just divide by 2 on both sides. You can factor it out, and that's fine too, but because of the equal sign, you are allowed to divide both sides by 2. And then I get x squared minus x minus 12 equals 0. Oh, you mean combine this? Good question. If I were multiplying, it would be x cubed, but since I'm subtracting, they have to be like terms. All right, what I am going to do, though, is factor now. I need two numbers that multiply to make negative 12 and add to what? Negative 1. Multiply to negative 12, add to negative 1. All right, what are those numbers? Multiply to negative 12, add to negative 1.
Negative 6. Or negative 6. I don't know.
What were you saying, Sonia? So you guys are doing a good job helping me think of numbers. Negative 1 times 12 makes negative 12, but it doesn't add. Negative 6 times 2 makes negative 12, but it doesn't add to negative 1. What else is there? Yeah, so negative 4 times 3 does multiply to negative 12 and add to negative 1. So we're going to go with negative 4 and positive 3. It's really good to think about all the possibilities first, so that you don't forget the ones you already tried. Then you set each factor equal to 0. So either x minus 4 equals 0 or x plus 3 equals 0. And you solve. X equals 4 or x equals negative 3. All right, first one. First thing we have to do is make sure one side is 0. Do we have that? Good. Next thing we do is look for a GCF. Did it have a GCF to factor out? No, it didn't have any GCF. So now we're looking for numbers that multiply to 2 and add to 3. What are they? 1 and 2. So I'm going to write x plus 1 times x plus 2 equals 0. All right, now this times this equals 0, which means one of them has to be 0. So you write them both out. X plus 1 equals 0, x plus 2 equals 0. There are two possible answers. So I'm going to subtract the 1 and get x equals negative 1. Subtract the 2 and get x equals negative 2. Two possible answers. Questions on that one? Yes.
So basically the number next to x, you just do the opposite of?
That works because our factors are pretty simple right here. On the bottom, we're going to get some slightly more complicated ones, but that's a good connection that you noticed, okay? All right. Number 2, first step is to make one side 0. What should I subtract from both sides? Yeah, I'm going to subtract this 3x from both sides. If you haven't done that yet, do that now. That gives me equals 0 on the right. On the left, I have 3x squared minus 3x minus 18. 3x squared and 3x are not like terms, so I can't cross them out. I just have to write them both. 3x squared minus 3x minus 18. Next step, I need to take out any common factors. Is there a number I can divide both sides by? Robbie says 3. Anybody agree? Yes. Remember, because it's an equation with an equal sign, you can just divide by 3 instead of factoring it out. That would give me x squared minus x minus 6 equals 0. Now I need two numbers that multiply to give me negative 6 and add to give me negative 1. Multiply to negative 6 and add to negative 1.
It's my math.
Who said that? Say again. Negative 3 and 2. Does that work? Is that what you got, Skylar? Negative 3 and 2? Okay. X minus 3, x plus 2. So I factored. All right, so we're going to write x minus 3 equals 0. And we're going to write x plus 2 equals 0. And we're going to solve them.
You get the 30.
Let me back up a sec, okay? So the question is, where did the 3 come from? So let's back up to this part right here. After I divided both sides by 3, then I was looking for numbers that multiply to make negative 6 and add to make negative 1. And so Anne suggested that negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So those were the numbers we put in our factors. All right, questions before we move on to the slightly harder ones. All right, examples 3 and 4. We have a number in front of x squared, and it's not a common factor because I can't divide the 2 by 3. So that means I have to do the harder method. And the harder method is when instead of multiplying to just the last number, you have to multiply to the 3 times negative 21. So I need two numbers that multiply to negative 63. And add to 2. All right, so Anne thinks she knows what they are, but let's see if we can figure them out too, okay? All right, so we said it's going to be negative 7 and 9. So what we do now, this is a harder method. We haven't done a lot of these. Bring down the 3x squared, then the negative 7x and the 9x, and then the minus 21 equals 0. So remember, this is the longer method. You take those two numbers that we just found and you break up your 2x into two pieces, negative 7x and 9x. Put your parentheses on the first two and on the last two. X squared and 7x, that does not have a number that I can divide by, but it does have a variable. What variable can I take out? X, thanks. What number can I divide 9x and 21 both by? 3, good. Do I have twins? I do. So I'm going to write 3x minus 7 times the outsides, x plus 3 equals 0. I'm running out of space a little bit, but I'll steal some space from this problem. All right, so either 3x minus 7 equals 0, and I add 7, 3x equals 7, and divide by 3. So x equals 7/3, or x plus 3 equals 0, which gives me x equals negative 3. So notice that negative 3 is the opposite of 3. That doesn't really quite work for this one because it was 2 steps. So x equals 7/3 here. 2 answers. Okay. In example 4, I've got a bit of a mess. What is the first thing I need to do in example 4? Make one side what? 0, yes. I need to make one side 0. So I'm going to do the opposite of what I have on the right. So to get rid of a negative 2x, I need to get rid of a negative 2x squared, I need a positive 2x squared. And notice how I write them under their like terms. To get rid of a positive 20, I need a negative 20. So I have 4x squared minus 4x plus 5 equals 0. All right, so Anne points out that I forgot to subtract the 20. Right, so 5 minus 20 is negative 15, right? Okay, so let's make that a minus 15 here. Okay. So now I'm going to multiply the 4 times the negative 15. I need two numbers that multiply to negative 60. And then they add to the middle, add to negative 4. I'm going to make my list again. Okay, so we said the numbers are 6 and negative 10, so we bring down the 4x squared. We replace negative 4x with those two numbers. Personally, I like to put the negative number first. It works the other way too, but I just prefer this. Wait, that's a plus. So negative 10x and plus 6x, and then minus 15. Okay, so you break your negative 4x into two pieces, and the way you figure out what those pieces are is you find the numbers that multiply to negative 60 and add to negative 4. Put parentheses on the first two and the last two. And greatest common factor of 4x squared and 10x. 2 what? 2x, because they both have x and they can both divide by 2. So divide out 2x for those. And I get 2x minus 5. 6x minus 15, what can I take out? 3, yeah, you can divide by 3. So plus 3 times 2x minus 5. Now I have twins. Okay. So 2x minus 5 times 2x plus 3 equals 0. And we're going to solve those. Two x minus 5 equals 0. Add the 5 and divide the 2. X equals 5/2. 2x plus 3 equals 0. Minus the 3 and then divide the 2. So x equals negative 3/2. So I get negative 3/2 and I get 5/2.